Okay, we'll go ahead and get started right now. Hello, everyone. Thank you for joining us and welcome to today's webinar, Quickly Assess Your UAV Data Quality in the Field. My name is Jody Lee and I'll be the moderator of this webinar. I'm excited today to be joined by Austin Coates, Product Manager and Technical Lead for PrecisionPass at Harris Geospatial Solutions. Austin will discuss how UAV pilots can immediately know in the field if they collected all the necessary data for their project. So before we get started, just a couple of housekeeping items. I've muted the phone lines for all attendees, so if you have any questions at any point during the webinar, feel free to enter them into the questions chat box, and we'll try to answer as many as we can at the end of the presentation. We are recording this webinar, and we'll have it up on our website at www.harrisgeospatial.com in the next couple of days. We'll also email you a link of the recording as well as a slide deck and some other information that will be useful for you. And we welcome you to share this email with your colleagues. So I'm going to now turn things over to Austin.
Thanks, Jody. As Jody said, I'm Austin Coates. I work here at Harris Geospatial. And yeah, I'm going to share a little bit about UAV data collection and how to assess it out in the field. So kind of the agenda for today will be an overview on Harris, a technical background on kind of the data that you need to collect while out in the field, a proposed solution on how to assess that data, and then also we can go into some questions and answers. So to start off with, Harris is a large multinational company. We have 17,000 employees worldwide. 7,700 of them are engineers and scientists, and we deal in a whole bunch of different areas, including air traffic, space and intelligence, weather systems, electronic warfare. We dabble in a whole bunch of different areas. The portion of the company that I work for is Harris Geospatial, and kind of our flagship software is ENVI. ENVI is an image processing software suite. We also have PrecisionPass, which I'll actually touch on today a little bit. This is a UAV assessment tool. Jaguar is a kind of a data dissemination as well as cataloging tool. And then the Geospatial framework is something that you can use to take all of these awesome tools and kind of put them up in the cloud. IDL is our data language that we use to write a lot of our software in. And then we also have deep learning capabilities as well. Our industries that we were kind of focused on are transportation, agriculture, utilities, as well as federal and civil government and defense and intelligence. We also have a custom solutions group here at Harris that can help with any kind of custom solution you need. So if you're, for example, an ENVI user and you need a specific image processing capability that doesn't come out of the box, our solutions group would be happy to help design and build that for you. And then in addition to the processing side, we also do data collection and dissemination. So we have Geiger mode LiDAR, which is a LiDAR system that you can use the data from. And then we also can acquire satellite and aerial imagery for you and derived data products as well. All right, so to just kind of get a feel for the room here, I'd like to do a quick poll question on how would you classify yourself with regards to UAV imagery? Are you a beginner, an intermediate user, or an advanced user? We'll keep it open for a couple more
seconds. All right, and here are the results. Austin, do you see the results?
Yep, I do. So it looks like we have a good distribution. So we have 46% are beginners, 41% are intermediate users, and 14% of themselves classify themselves as advanced users. So I'll try to kind of tailor this talk to match the audience. And yeah, hopefully everybody can get something out of this. So with UAV imagery, after you've collected it, the big question that everyone asks is, did I collect the data that I was seeking, and do I have what I need to solve my problems? It's kind of a intense experience. Once you've collected all your data and you kind of flip through it out in the field, maybe you look at a couple of the images, but to really know if you have what you need is really hard because the software usually isn't there. you have to go back to the office and then run something like an orthomosaic or something on it to produce a product in which you can use for either a qualitative assessment, kind of just looking at the imagery, or you can go into a more quantitative spectral analysis using something like Envy or another software suite. So yeah, but when you're out in the field, it's really difficult to determine what exactly you have collected and is it appropriate for your final application. So I'll kind of go through some of the things that people encounter when out in the field, and also some of the ideas that you need to keep in mind when collecting your imagery, as well as when recording the data that you have collected. So as far as a mission definition, depending on what your target area is or your collection boundaries, you can either fly something like a grid pattern here, a single corridor, or a dual corridor. So the grid pattern would be something for like say an agricultural field. You would fly kind of a lawnmower pattern over that field to hopefully acquire enough imagery over the same areas that you can get lots of good tie points and build your orthomosaic. If you were going to fly say a road or railroad tracks or a utility line, something like that, maybe you would fly a dual track or a single corridor. The dual track is really nice because once again you have more overlap between those images, so your orthomosaicing software can help find those tie points. I know when I do things in-house, I use NV1 button, and as long as I have enough overlap forward as well as side lap, I can get a nice ortho. But if I just have a couple of tie points here and there, it just doesn't seem to complete. So it's really important that your mission definition is spot on. So kind of what goes into defining a mission is your collection boundary. So you have to think about where you're collecting and how much information you need to collect over that area. So here we have a representation of a collection boundary. It's a center pivot field. Out in the field, you can watch your drone fly and you kind of get a sense of where it has collected, but without really laying the imagery on top of the polygon, it's hard to determine what exactly you have covered while out in the field. Did you get enough tie points over that control target that you had out there, or say you have a calibration validation target? Did you cover it adequately? It can be difficult to determine these things without being able to really kind of dive into the data and give it a quick look. So I talked about it a little bit, but the forward lap and the side lap. So when you're flying down the field, you have a forward lap, so that's image to image, as well as when you're coming back, you have side lap, so that's overlapping image pairs. Depending on what your collection is and kind of what you're hoping to image, it's important that you tailor your forward lap and side lap to that collection type. So for agricultural fields, you usually want to get a lot of tie points in there so that you can mosaic the field back together. It's hard to find invariant features in agriculture, and because of that, you want to have a lot of overlap. Whereas other things, so you're flying over a city or something like that, it may not be quite as necessary to have a very, very high overlap, just because there's so many invariant features that you can do a really good job orthomosaicing it. So kind of all of these parts a lot of people are already familiar with, but what exactly is being used to generate, say, an ortho, or even just analyze the data in a usable format? So if we have a UAV here, the information that's actually coming off of the UAV itself is usually roll, pitch, and yaw, as well as kind of the longitude and latitude, the geographic information about it. So the roll, pitch, and yaw comes out of the IMU, and then the GPS will tell you the altitude as well as the position on the Earth's surface. So this is important just for overlaying the imagery on the ground. It's important to know where your imagery was collected so that then you can place it appropriately. The roll, pitch, and yaw is important because if you have a fixed camera, something without a gimbal on it, however your aircraft is oriented will be kind of the looking direction of the sensor itself. If you do have a gimbal, you also will acquire the roll, pitch, and yaw from that gimbal and then place that into the model as well. In addition to the gimbal parameters, also camera parameters are important so that you can reconstruct how that image was captured. So things like the focal length, as well as any kind of band information. All of this information is usually written into either an associated metadata file or a header file, or a header within the image, so using EXIF tags or something to that effect. These tags are not so difficult to get at, but you usually need a piece of software to look at them. As long as your camera is set up right, you don't really have to worry about it, but sometimes it's nice when you're out in the field to give it a quick look and say, was my IMU writing to this file appropriately, and when I get back, am I able to use the information that it did record? We get a lot of questions from people saying, I collected all this imagery, I don't have a chance to go back out and recollect, however, I'm missing data. Is there anything that you can do to kind of reconstruct this collection? And our answer sometimes is, yeah, we can help out in some ways, and then other times it's no. Unfortunately, we don't have any tools in our toolbox to help reconstruct this. So it's really important that the imagery is collected correctly up front, and the easiest way to do that is collect your imagery and then look at it and validate that everything was in fact collected, so that if you have a problem, then you can just change it up in the field, you can change some parameters and go and refly. One more thing to take into consideration when collecting imagery is the topography of the ground in which you're collecting it on. This isn't so much important for out in the field per se. It will play in a little bit later on, and I can explain that. But when you're creating an orthomosaic or trying to overlay the images on the ground, you can see here that this kind of image plane is tilted slightly because it's on the side of a mountain. So everything is always projected flat, but the ground and the earth aren't flat. So it's important to realize that your image actually has to be kind of maneuvered around so that it can lay flat on the ground, or lay flat in your final representation. So a digital elevation model helps a lot with that. If you're flying a push broom sensor, it's also important to realize that it kind of collects in a little bit different way than a full frame camera. So each line is collected as the camera moves along. So a regular full frame camera will take a picture and it's, say, 1,000 samples by 1,000 lines, so it makes up a big square, and all that data is collected in one shot, whereas a push broom sensor just collects one line at a time. So it could be like 1,000 samples wide and then only one line tall. And while it's doing that, it collects and flies along. However, if you have a wind current or something happen in the middle of the flight, you can get gaps in these scan lines. And unlike a frame camera, you really can't flip through each scan line and determine what's happening in there. So you need a tool to be able to assess this. Gaps are not always a huge problem, but they do require the final analyzer to interpolate over those gaps so that you can get a full image of what you're looking at, and the less interpolation, the better. So once again, it's best if you can identify the amount of gaps and how many you have while you're out in the field and just recollect if you have a problem, as compared to having to get back to the office and realizing, oh no, this data isn't what I thought it was going to be, I need to go back out. One last thing is actually the imagery itself. So not only the position of the imagery and how it was collected, but the actual data that is collected inside of the image. So you can have under and over saturation, depending on the cameras that you use. Some of these cameras auto correct for these sorts of things, but they can be tripped up by, say, a really shiny roof on a pickup truck or something can throw off the white balance on an auto-focusing camera and give you odd results. So it's important that you kind of flip through these while you're out there to determine, did I collect what I thought I did collect? So was I undersaturated or oversaturated? Did I have enough contrast? Did I have too much contrast? And this can be done just visually by flipping through the images, or you can use the histogram within the image to determine whether or not these images have enough data within them to be used later on. So that was kind of a lot of parameters to keep track of, especially if you're just trying to manually go through each one of the images that you just collected or each one of the scan lines. You got to open it and look at all the different parts of it. It makes it a lot easier if you can just project these things into a nice user interface. And so we have this tool, PrecisionPass. So PrecisionPass is a standalone tool that it doesn't require an internet connection or anything like that. It goes with you out in the field and can be run on a laptop. And it automatically analyzes all the statistics that I talked about earlier, all the EXIF tags and GPS coordinates, as well as the saturation and contrast for each one of the images. Let's take a look at the user interface here. So what I have displayed here is just the image overlay, so you can see qualitatively what's going on. So if you knew your collection site, you could look at it and be like, oh, okay, I did get the road well enough, and I can see a pickup in there, and so you can make a quick assessment that way. Once again, this is only using the GPS information as well as a digital elevation model that we ship with the product. So it's not a full ortho, and it's not doing any kind of bundle block adjustment. And the reason behind that is we just want to make sure that this is as quick as possible. So this image here has a little over 100 frames in it, and it took me less than a minute to load it in. So you can imagine you've just collected all of your imagery, you can come back, toss it into your laptop, take a look at it, and be like, yep, I'm good to go, and then travel on. The way you determine whether or not you're quote unquote good to go would be by looking at these red X's, yellow triangles, and green check marks. So each one of these indicates whether or not you passed the predefined criteria. So for example, in this collection, I'm saying that we didn't pass the 5 centimeter ground sampling distance. So the hope was that each one of these images would be collected at a GSD of 5 centimeters or better. They weren't, and because of that, it shows 0 out of 160 frames achieved this 5 centimeters or better. So this would be an indication to me that I need to go refly and probably fly a little bit lower. As far as the forward overlap, this is giving me a little yellow triangle saying, you're kind of on the cusp on whether or not you should refly, make a determination, and then go from there. So it's saying that I wanted to achieve at least an 80% or better forward overlap. So I did that with 140 out of 159 frames. So once again, I can kind of determine, well, I think it looks okay. It looks like I got everything that I wanted to get. I'm going to risk it and take it back to the office. As far as the side lap, I said I only needed 40%, and we well achieved that. And then with the contrast and saturation, we go through each one of the frames and determine whether or not the contrast and saturation are appropriate for later use. And so it shows here that they both are. The way you can change all these values is under File Preferences. It pops up this dialog, and then you can go in and change all of the parameters. So for example, with the ground sampling distance, I'm saying I'm looking for images between 0 and 5 centimeters. A successful collection would have at least 90% of the images achieving that, and a failure rate would be anything below 50% collected. So if I was between 50 and 90%, it would give me that little yellow triangle. Above 90% would give me the green check mark, and below 50% would give me the red X. All of these can be set within the application itself, or they can also be predefined using a JSON file. And so if you have, say, a large team or something, you can predefine all of these, put them on the laptop so they can go out, and then nobody ever has to even go into this preferences file. They can just simply look at the visual indicators and make a determination on whether or not they need to recollect. So we have a couple more looks here that we can analyze. So this is just looking at the polygons. You can look at the areas that are darker blue and the areas that are lighter blue. Any area that is a darker blue color indicates that there were a lot of overlap and a lot of coverage in that area. The lighter blue regions show that there was only a little bit. So this is just a quick representation of some of those statistics over on the right. You can also look at the flight line. So this is derived from the flight path of the UAV. So you can compare this to the flight line that you had programmed in using some sort of flight planning software to say, okay, I told the UAV to fly in this manner. Did it achieve that? If not, where did it go wrong? And then you can make a call on whether or not you need to refly. If we were to click on one of those indicators on the right-hand side, for example, I clicked on the yellow triangle there, it pops up and it displays all of the areas in which have an issue. So I clicked on the forward overlap, and it's showing me that here on the edges there's a couple and a few in the middle that are having an issue. If you were to click on one of those, it would pop up in the left-hand side and show you what was going on. So for instance here, I was looking at forward overlap. We only achieved 78% on the image that I selected, and so that's why it's being indicated as it didn't pass our criteria. It also gives you a visual representation here so that you can see what's going on. If you do a shift left click on any point in the image, it will return all of the overlapping frames in which you clicked on. So this will give you the number of looks that you have at a single point. This is important if you have like ground control targets or CalVal targets out there that you want to make sure that you cover it adequately. You can click up this way and say, oh, okay, yep, I have enough looks over it. If you use the cursor location in the bottom left-hand corner here, you can also zoom into an area in which you know the location of it. So once again, for a ground control target, if you knew that it was at some longitude and latitude, you could simply move your cursor to that location and then check how many overlapping points you have. Currently, the tool supports MicaSense, Tetracam, and DJI sensors, as well as the Corning push broom sensor. If there's a sensor that you're currently flying that's not on this list that you would like the tool to support, please get in contact with us. We're more than happy to add new sensors and help you out in any way that we can. So yeah, we can open it up to questions now. If there's any questions out in the audience, I'm more than happy to answer a few.
Yeah, great. Thanks, Austin. Yes, if you have a question, just enter it into the questions chat box on your GoToWebinar dashboard. And as a reminder, we are recording this, so all the questions will be on the recording as well. So our first question is, how can you do a SFM with a single or dual corridor collection regime? Don't you need 3 passes to get the overlap you need?
It depends on what software you're using. The more passes, the better. But yeah, it depends on what exactly you're using to do this. I know that we can get a good registration out of 2 passes using NV1 button. Some other software packages can achieve it with others. So yeah, it just depends on the software package that you're using as well as the number of the passes that you have.
Great. Someone asked, how can we access this program?
So like I said before, this is a standalone tool. It's sold through Harris Geospatial. So if you have interest in it, please contact us and we can help you out either with a trial license or get you a full license to it and go from there. Great.
And then continuing on that, someone says, I'm a part of a large organization with many UAV pilots. Does PrecisionPass have flexible licensing options?
Yeah, it does. So our standard licensing is a subscription-based model. If you need something different, do please contact us and we can work something out with you. We can make it work. But yeah, please get in contact with us and we can help you out in any way we can.
Great. Next question, have you considered adding slant range collection data to the software?
Yes, we have. So we're trying to add new sensors all the time. If you're currently using a slant range sensor, please get in contact with us. Once again, we can see how quickly we can add it for you, or we can get it on the backlog, and hopefully it'll come out in a release soon.
Great. Next question, do you suggest speed and altitude of the UAV to fix some of the problems?
So we actually don't make any suggestions as far as the problems. We just try to draw your attention to them. So this tool can kind of help you learn those sorts of things. If you are new to flying, you can take a look at it and go out and fly a couple of times, see what the tool tells you. If you see that, oh, if I fly faster and higher, I get this GSD and this coverage. If I fly slower and lower, this is what I get. And that way you can kind of get an inclination for what you need to achieve.
Great. Jim asks, can you set different contrast and saturation thresholds for different spectral bands?
Not as of right now. If there is a certain sensor that you're using, or if there is a certain contrast level or something like that, or yeah, if this is a need for you, please get in contact with us and we can talk through it with you. Like I said, our custom solutions group could either build a one-off solution for you, or we could once again try to get it on the backlog.
Great. Next question, do you have a flight planning tool, or which one would you suggest for DJI?
We do not have a flight planning tool. we as far as UAVs, this is our kind of field assessment tool. So we are open to taking in any kind of imagery that you have. But as far as planning the actual flight itself, we don't have anything. And yeah, we try to keep it pretty agnostic as far as the tools and sensors that we use. So yeah, it's there's a lot of them out there. I know DJI has, I think they have one of their own, and other people provide services as well. So yeah, I don't really have a strong recommendation as far as the flight planning tool, but yeah, just yeah, once again, Google search. Yeah.
Okay. How often do you release new versions of the software?
So we're trying to release as rapidly as possible. We want to make sure that whatever we release, the market wants to support. So the idea was to get this out quickly and then talk to everyone, talk to people like you guys, and find out exactly what you need in the tool so that when we can respond to that. So yeah, I mean, we're currently developing new tools, and so yeah, soon we're trying to be very quick, but we don't have a really strong cadence in our release cycle. So it'll be driven by the market.
Great. A couple more questions. What are the next steps for you typically see in the workflow related to UAV data collections?
Yeah, so kind of I touched on this earlier, but so yeah, you would plan your flight, you go fly, collect your imagery. You can analyze it with PrecisionPass here to determine whether or not you collected the imagery that you needed. And then you can go into something like NV1 button and orthomosaic the imagery. And then once it's orthoed, you can either analyze it just from there, you can make determinations on what you want to do, or you can take it into something like NV and start to go a little bit deeper into the image processing side of things to pull out features, for example, or look for patterns within your imagery or do a classification. If you're doing agricultural work, we have a tool called NV Crop Science that you can use to get down to individual plant level and get the health of each plant, or you can do it based off of zones. And yeah, there's a whole host of different things that you can do.
Great. And then can PrecisionPass be tailored to meet specific sensor or project needs?
Yeah, very much so. So I touched on it kind of earlier as well with the custom solutions group. So if there's something very specific that you need to have this tool do, we are more than happy to build it for you. Or let's start a conversation. If there's something that you would like to see in the tool that's not quite there yet, please let us know, and we'd love to add it and make sure that we're supporting what you're trying to accomplish.
Great. We're going to take this last question. If the GSD is not sufficient, would you consider modifying the software to compute and supply a recommended altitude for a reflight?
That's not beyond the scope of the tool at all. If that's something that you need, yeah, do contact us, and maybe we can work together on getting you a solution.
All right. So with that, we're going to wrap things up. We appreciate everyone's attention on the line, and thank you, Austin, for the informative presentation. If we didn't get to your question, then someone will follow up with you. And just a reminder that we recorded this webinar, and we'll send you the recording and the slides in the next couple of days. It will also be available on our website at www.harrisgeospatial.com, and we encourage you to share it with your colleagues. So thank you, everyone, and have a great rest of the day.